Hi guys. So in this video we are going to cover the Terraform basics, and we will understand the Terraform syntax, and we will create the Lambda functions, AWS Lambda functions from the code, not via UI. As you can see this function that I have already created when I'm testing this project. So we will create two more functions, not via manually like create function and selecting the node.js 24, giving their function name and giving the code zip file. So we will not create it by manually. We will use what? Let me bring into the frame the Terraform. What it is? It's the Terraform. Basically, it's an open source tool, not an open source. Previously, it was open source, for n- but developer can use this. Uh, it's an tool to create the infrastructure via code. So it's a tool for the infrastructure as code, popular tool. You can There are also some other tools like Ansible also. So let's see how how we write this. How can we write the syntax of this Terraform, this open source tool, not open source, correct me. So let's go back to the code base and write some code. So here it is, our ID VS Code. I've already created these two functions. Let's create a one more folder, Terraform, and open in terminal. That's good. Now first we have to create some uh, provider. We have to install the provider like the AWS provider or the Helm provider. With the AWS we can use the AWS resources, can see the types. It's like when you install the types of something in Node.js, you can import the type and see the packages. So it's like you are downloading the provider from external on from the internet to your local directory. We will not push that, like we did not push node modules to the GitHub. Is the same as here. We don't push the provider code base into the GitHub. So the first file we will create the provider.tf. For the provider, go back to your browser and write Terraform. We are creating the AWS infrastructure, so download the AWS provider, Terraform AWS provider. Go to this first link and here it is the code. Copy this, paste it. We don't need a custom VPS. In the future video I will create a video where we create the VPC, net, internet gateway, route tables, EKS cluster from the Terraform. So make sure you subscribe and you have hit the bell icon for the latest updates. So that video will be soon uploaded. So copy this provider and this Terraform and paste it right here. So let's understand what it is. There's the syntax where you install some providers. So that's how you install the providers in Terraform, and that's how you provide the resources. These are the blocks. As you can see, provider. There are other blocks also, like resource. Resource what are the resource we are going to use from this AWS provider, like the IAM roles, Lambda functions. That's the resource. Then we give the name, and we give the tags and the key value pairs, what we have to define. So let's change it to the AP South one. We are going to create this infrastructure on the Mumbai server, and that's it. And what you have to do, and make sure you have Terraform installed. If you don't know how to install it, go to the Terraform install. That's the HashiCorp official website. If you are on Mac, you can use the Brew package manager. If you are Windows, download this AMD64 and update your environment variables and copy and paste the path in system variables. If you are in Linux, copy paste this command, so this will get installed. Then if you write Terraform, a long list will show up. If this list is not showing up when you write this keyword Terraform, that means you have made a mistake via installation. So make sure your installation was correct. Now we will write Terraform init, just like we do npm install. We will do Terraform init. It will check if there are new providers or not. Then it will install the new providers into this local code base. So Terraform init, as you can see, installing HashiCorp AWS 6.5.6.51.0. That's the latest I was. As you can see, this .terraform has been created, and if you want your resources, if you don't want to store your resources information here, you can use the backend. Here you will write S3, and you can store the resources in the S3 bucket. So we will understand where after this playlist, after this project playlist, that's called remote backends. It's an important interview questions. I will cover it when I create the Terraform video in detail. In for this project, let's quickly finish it. It's not that hard. This is not going to be the complex Terraform. As you can see, it has created this .terraform. It has installed the AWS provider according to the Windows. Now what we will create next is the some IAM roles. So let's create a iam.tf file. Let me check my mic is working. So what we are going, we have to create an IAM role. What is IAM role? When you want to give permissions, specific permission to your AWS service. And what's the AWS service in which we have to give this role? That's the AWS Lambda. So instead of creating user and in Lambda providing the access key ID and secret access key, is generally better you create a role for the security purpose. And IAM users not rotation wise, it has a fixed keys security if it is leaked, uh, it means आपके लग चुके हैं. So anyone can use your service if you use IAM users, but if you use IAM roles, so IAM roles provides also some keys rotation. So it is, if you are creating any roles, any service, if you are using the AWS services, use the IAM role, not IAM users. So first we have to create a what, a resource, a AWS resource. IAM role is also an AWS resource. So we will give this a resource keyword. What it is, it's a block, and we will give the resource name. What the resource name we are going to create is the AWS IAM role. Now what's the name? It's the local name. That's not the name of your role. So let's say it's Lambda and give it a name. Let's say Lambda role. Assume role policy. What is assume role policy? We have to create a policy that this Lambda service can assume, and in future or in next steps we can give the specific permissions to this policy, to this role. So let's create a policy. So how can you create this? As you can create via two ways. You can use the JSON encode function, or you can use the Terraform. The Terraform provides the data block. So what are we going to create? We have to create AWS IAM policy. What's this data? It's a generally a template where you will just put the values and it will create a template like in Helm where we just update the what, image image names, image tags. That's the same. So we have to create a statement, and effect will be allow principals type service identifiers lambda dot amazon aws.com, and actions sts assume role. Now we have created this document, this template. Now we have to paste right here. How can you put the value right here from this block to this block? Like in JavaScript, we destructure the objects. How we access the objects in JavaScript? Let's say Let's say this is an object. Let user name. So how can you access this? If you write console.log user.name, something like that, then you will get this print. That's the same we have to write data dot. As you can see, it automatically detects. If you don't get this automatically detect, go to your extension, and I have already installed this HashiCorp Terraform extension. Make sure you installed in your IDE if your IDE provides. If not provides, manually write it. Dot JSON. Now we have created the role and we have assumed the policy. Now next we have to create a policy. Create a policy in which we give some specific permissions. Then we will attach that policy to this role. This policy is for the assume that Lambda can use this role. This is for that. Here you will see how you can define the policy in other way. So next resource we have to make AWS IAM policy direct. No, we are not using template. You can use the template, but I will show you other method. Give any name what you want, and name is the lambda. Give anything name, shorten URL policy, and in the policy tag write JSON encode, not decode, encode, and open a object, and here you have to manually write. In the data template you are automatically getting what you have to fill. Here you manually write the key and the value also. You don't have to remember these things. In interview you can use the browser, you can use any resource, you can get the help from the browser. You don't have to remember, you don't have to learn all these things, version 20, 2012, 1017. You just have to learn what permission you have to give. That's what is important. Now first is we have to give some DynamoDB access. Effect allow action. Let me see, there is DynamoDB policy instead of manually writing. Yeah, here it is. Copy and paste it right there. Now we have to give some. We can use this template dynamo db access fact is allow and copy. First we have to give is the get item, it's important. Second we have to write the put item. Third, update item. Update item we don't need because we are just putting and getting the values. We don't need to describe table query and scan, we need it. Yeah. Now we have to give the resource of the our DynamoDB table. This open an array, give the resource DynamoDB table. In the next video we will create this table and put the value by using this format, this using this interpolation. When we create the DynamoDB via Terraform, but in this video we are going to test the Lambda functions and create the Lambda functions. So for that we have already created. Oh, I have deleted it. So let me make another table. So it will take some time. I have created the table again, as you can see, bit.ly table, and copy this ARN, paste it right here, and we have to paste one more ARN for this index. It is getting created. In the previous video we have already discussed why we are using this GSI, global secondary index. You can see the previous video, you will understand there. By the time it is creating, let's complete our infrastructure. Here we will write index, and you can write the index name URL, or you can give it a star, or you can give resource as a star. It will use the all resources in the DynamoDB. If you have worked with DynamoDB and you have multiple tables there, use this. If you don't want this hassle and your DynamoDB table is fresh, no tables at all, use the star. And it is created. Next we have to create what? We have to create some policy for the CloudWatch, where you can see the logs of your console, logs of your functions. So right here, CloudWatch logs. Effect allow create log group. That's what we need. And logs, create log stream. Logs and put log event. That's three we will need. And give resource star. We have created the policy. Now we have attached this policy to this role. So the next resource we are going to use the AWS IAM role policy attachment and give it a name lambda role. What's the role? AWS IAM role dot lambda dot name and the policy ARN AWS IAM policy dot lambda dot ARN. So that's how we have finished the IAM stuff. That's the only rules and policies we need for this project. Yeah, that's it. Now we can move forward to our creating the lambda functions. Let me check our GSI is created or not. Still getting created. So first thing, in lambda we cannot paste the code as the copy and paste. We have to create a zip file for that. So go to your code base. So in the zip file you have to include the node modules also, because in lambda you cannot do like npm install. You can do, but we want our lambda to be lightweight and we will thoda easier. So we will create a build command here so that we will use the es build, which will take this index.ts, which will take this node modules and create one file index.js, and everything was present there in one file. Every node module, every function in one file, everything was there. So let's create a build. So we will write npx es build, give the path of your file, bundle, the platform is node, the target equal to node 24, where we want the output we want in the dist index.js. And now let me open in terminal. If I write npm run build, you will see a dist folder where index.js, from that index.js you have to convert it into a zip file and provide it to the Lambda. As you can see, it is asking me to install the ES build. Press Y. It will take some time. Not time. As you can see, the size of this is 1.3 MB, and index.js everything is present. Every node module, every type of the DynamoDB, everything is right there. So copy the same build and go to your URL, shorten package.json, build command, this is the URL shorten, right? And run npm run. There's already a dist because we are delete this dist folder. Npm run build. As you can see, the index.js is got created. Now close this everything. We don't need this now. Now we have to convert this file index.js, this in dist index.js, into a zip file because that's Lambda expected from you. So we can use the Terraform resource or a provider by using that we can create the zip file. So what it is, it's the archive file. As you can see, archive file, and give it a name, bit.ly function zip. What it is expect, what are you going to create? It's a zip file. What's the source file? Bit.ly shorten function zip. Copy the path, copy related path. That's what we need. Dist index.js. That's the source, and what output we want. Copy this. Function.zip. Copy. Same for the redirect. Bit.ly redirect. Copy the relative path. Now when we run the Terraform apply, it will create the zip file. From that zip file we will use that zip file in the Lambda resource. So now let's create our Lambda function, AWS Lambda function, and give it a name, bit.ly shorten function. Function name, give the same name, and where's the file name? It's the shorten one. So data dot archive dot output output path. Let me zoom it for you. And we have to give the source code hash, what it is, data dot shorten function output base 64 SHA 256. This one you have to select. Handler, what's the handler? What's your function name inside the file? Our function name is the handler, so we will write index our file name, and handler is our function name. What's the runtime? Node.js 24. Make sure you have 24 plus Node.js version. And what's the role? AWS IAM role, this lambda.arn. And we have to provide, as you can see in the function, there's an environment variable called table name. Copy this and here write the environment tag variables and give it a table name, and paste your table name right here. That's the bit.ly YT. GSI is created. Bit.ly YT. If you don't want to write like this as a, it's not looking good, you can create a variables dot tf and write a variable block and give it the AWS DynamoDB table name, and what's the type of it? It's the string. What's the default value? It's the bit.ly YT. There is a hidden method also, not variables. By if you use the variables, you have to push it some. We use the non-secure values right there in the variable. In just like in Kubernetes, we use the config map for the non-secure values. That's how the variables work. Here we will write the non-secure values. We use the Terraform dot, there's a file extension .tf-vars. We don't push it to the GitHub. By using that, we give our environment variables right there and fetch right into this. In this project, we are not going to see that, but in the upcoming videos of the Terraform, I will tell you about this. I will teach you about that. And table name, because in this project we are going to create the table via the resource, DynamoDB resource, then we can directly fetch the name from that. So nobody wants gets the access of a table name. Now how can we access the variable value? Just add the var dot AWS DynamoDB table name. So that's our shorten function. Let's copy and paste. Copy and paste. It's not getting copied. Yeah, now it's the bit.ly shorten redirect redirect redirect. So the role is same. So data.archive file.bit.ly redirect function zip. Everything's fine. That's good. Now we have created the function, and if we have to see the logs, we have to create the resource also for the AWS CloudWatch. If we get any errors, CloudWatch log group bit.ly log group. So we have to give a name. Name is like AWS Lambda. In a string, like we is the same as JavaScript. You know this method we have used a lot of times, where you want the dynamic values in the string. You can use this format. In JavaScript we use this colons. We will give a special name, lambda, sorry, AWS Lambda Function dot a bit.ly shorten not shorten the redirect dot function name function function name, and retention in days 30. Now, yeah, for the testing purpose it's good. And let's see, you can create a log group also. That's your task, to create the log group for the shortened one. And in the next video we will give the permissions about, we have to, there's work remaining on this file, like the permissions to the lambda for the API gateway, like if this post method hit, use invoke this function, like that ways. In the next video we'll cover that. So let's test it out. First, earlier. First write Terraform validate, check if there is any errors or not. As you can see, there's an error, missing required provider, because we are using the archive file. And how can we install this provider? By using Terraform init, installing HashiCorp archive. Now we do the Terraform validate. Everything is fine. Now we write Terraform plan. By the plan you can see the values are correctly put it or not, what resources are going to create. As you can see, 6 resources are going to create. The value is correctly put it from the variables. You can see this function will be getting created in the AP South 1 region. See the index.file name. Now we will apply by using Terraform apply. Enter the value yes. As you can see, policy creating, policy created, function is creating, IAM policy attachment, policy has attached successfully, function is created, the shorten function, redirect function is also created. Now go to the Lambda. You can see there's 4 functions. Go to the shorten one. See the code source. There will be one index.js file, as you can see. So everything is correct. Now let's test this function and create a new event. Let's say test. It's going to be URL and give some random URL like this. Paste. Let's test it out. Status code 500, message expression attribute values must not be empty. We have mistakes, some error. You can see this logs in the CloudWatch. We have made some mistake. Index.ts. So the mistake is I have wrong imported this query command from this client DynamoDB package. The correct one is I have to import this from this lib DynamoDB. So that's okay. You can see now you have created your resources. How you can destroy? If you are creating by manually, you will go to this function, select it right here, actions, delete, right? So, so when you create your infrastructure by using these type of tools, they give you some advantage. You can delete your resources instantly, and all of them all of them at one time. How to do it? Terraform destroy auto approve. What's this auto approve flag? So we don't have to give this uh, value yes separate. Now it will delete your resources. As you can see, 0 to add, 0 to change, 6 to destroy. You can reapply it. It will reapply the zip files. So I have to show you the destroy function. That's what I've done. So now let's delete this, delete the function, delete this. If you don't want to delete this, okay, but for the safety purpose or the extra safety, I'm deleting. If it doesn't get overwrite, so it will give the error again. So I don't want, so I want to remove that extra. From the error from my side, you can test it out. It will overwrite it or not. That's your job. Let me take a look on my mic. Everything's good. Now run the npm run build. Npm run build here. Done. Now reapply Terraform. Apply. As you can see, after deleting, there's only two functions. Auto approve. It will take some time. Let's wait. A functions is created. Go to your shorten function and let's test it out again. Test it. As you can see, our short code is generated successfully, and if you see the JSON, I have changed it because in the code I have write like the API gateway type. So as you can see, this event is the API gateway proxy event. So you have to give the type like that, in which we are getting the URL from the request body event.body. So in the body we have write like this, and if you go to your DynamoDB table. Oh, there's an internet issue, so let me fix it. Let's wait. So go to your DynamoDB table and tables bit.ly it. As you can see, get the table items. There's the short code is generated for this. And in the next video we will create the URL for the redirect. Now it is working fine. Currently it will not work because in the redirect function, as you can see, we are expecting an event. From that event we are getting the short code from that parameters. So we need API gateway for this to work, to test. So in the next video we will create our DynamoDB table from the code by using Terraform, and we will create the API gateway and we will give the specific permissions to this Lambda. So that's it for the video. Make sure you like the video. I hope you found it information wise, you found it good. And make sure you watch my other playlist also. Those are worth watching. And thank you for watching this video.